Hi everyone. A very good evening to all of you. Now we are going to discuss about the equilibrium of a system. So how the questions will be asked based on this and what are the basic things required for this one. So the very first thing what we should know to solve the questions based on this is all about what are the natural forces. That means the very first thing is for every mass there is a gravitational force. So the gravitational force nothing but weight of the body. So what is the weight or gravitational force is mg. It always acts downward. That means towards the center of the earth. And when there is a light string and it is tight, then there is a force develops at every point and that force is nothing but tension. T is tension in the string. And if the string attached to the body upward, then the tension is upward. If the string attached to the body right side, then the tension acts rightward. Like that, depending on the string direction, the direction of tension will act. Now, when two surfaces kept in contact, there is a force called normal reaction, that is perpendicular to the surfaces. And upper body will get upward force, lower body will get downward force. And if two bodies are kept in contact side by side, rightward body will get rightward and left side body will get leftward. And that common force, equal and action, equal and opposite, just like action reaction pair, we call it as normal reaction or just you can say reaction force. So these are the three main forces which will come in most of the questions based on equilibrium. So equilibrium means what? What is the equilibrium is? And also one more thing, see, one more also we have to remember that is pseudo force. Pseudo force means an imaginary force and that is given by mass of the particle into acceleration of the frame. So when there is an acceleration for any frame like a moving bus and if any body is attached like we are sitting inside, then we experience an imaginary force due to the acceleration of the system or due to the acceleration of the frame on which we are sitting. That force is pseudo force. So based on this also sometimes they'll ask the questions. Now, how to deal with equilibrium of a system? Generally, when you deal with a equilibrium of system, first thing is the resultant force on the particle on the system is zero. Nothing but the resultant force along x, along y, as well as along z. All the resultant force must be zero. Generally, when they give in plane, two directions only will be there, x and y. So what you have to do is, the very first thing is choose x and y axis. So how to choose x and y axis is, most of the time you can choose horizontal as x axis. So x can be either horizontal or if the system is not in equilibrium, then in which direction the system can move. That means system will have acceleration, possible direction of motion. So either horizontal or possible direction of motion you have to consider as x and the perpendicular to x we will consider as y. And if any force not along x and y, then resolve into components. Resolve into components. So you need to divide the vector into two components. Just like if this is one force and this is x-axis and this is y-axis you have chosen. So you have to divide them into components by finding the one of the angle. So you should know the vector resolution also. Then only you can do then only you can solve the numericals based on equilibrium. So these are the things you need to understand. So represent the or better to say, you should know how to draw free body diagram also. So free body diagram means, better to say, free body diagram represent forces and resolute along x and y axis, and that is called free body diagram of a particle or of a block or of a system. Now you have to balance x direction separately and y direction separately. Now let's see few questions based on this. Like a body of mass 10 kg, a body of mass 10 kg is suspended by a rope and is pulled to a side, is pulled to a side by means of a horizontal force, so that the rope makes an angle. So a body of 10 kg is suspended by a rope and is pulled. See, just like one rope is there and it is, a body is suspended from it and is pulled to side by means of a horizontal force. That means now we pulled it aside by applying a horizontal force. So here string is there means what force will be there? Tension. So that it makes an angle 60 degrees with the vertical. So that the tension in the rope. Now here downward weight will act. So external force, tension and weight. Now horizontal if you consider as x, vertical as y, F and W are along x and y. So no need to disturb them. Now here this is 60 means this is 60, then this will become t cos 60 and this will become t sin 60. Because why I have chosen to divide t into components is t is not along x and not along y. So that now if you consider x-axis, f must be balanced by t sin 60 and w must be balanced by t cos 60. So if you solve these two equations, then you will get the answer. Now, the other one is a body of mass 10 kg is suspended by a rope of 50 centimeter long and pulled to a side through a horizontal distance of 30 centimeter by means of a horizontal force. Then what? Then that horizontal force is again same thing, but in a different manner. See, this length they are given now, this length, and it is 10 kg. Now you pulled it aside. Now the horizontal distance they are telling 3 centimeter, sorry 30 centimeter, and this length of the string is 50. That means we don't know theta. But if you take here sine theta equal to opposite by adjacent, sorry hypotenuse, that is 30 by 50, that is 3 by 5. Now sine theta is 3 by 5 means theta is how much? That is 37 degrees. Sine 37 is 3 by 5, sine 53 is 4 by 5. Now you can get cos theta also. So cos theta will become 4 by 5. Now tan theta will become 3 by 4. Now same thing again, here weight will act and here horizontal force, here tension. Now again you will take the component, this is theta. Now this will become t cos theta and this will become what? T sin theta. So that again f is balanced by T sin theta and W is balanced by T cos theta. Now sin theta, cos theta values we know. And if you divide both of them, then you will get the equation. Just like F by W equal to tan theta will come. Tan theta value is how much? 3 by 4. And we have to find F. And W equal to what? W is nothing but mg. So that F value is mg tan theta. Substitute the values, you will get the answer. Now one more thing here, they have given that it is in equilibrium, it is balanced. Now tension T1 and T2 we have to find. Now when you consider, see here this point is in equilibrium, this junction. So this junction when you consider, here one tension T1 and here one tension T2 and here weight is acting, that is 80 G. Now here when you consider the angle, this they have given 60, so this is also 60, geometry, simple geometry. Then this is 30. Now you take this as x-axis and again this as y-axis. Then you will get the components like this is T1 cos 60 and this is T1 sin 60. Same way this is T2 cos 30 and this is T2 sin 30. Now after this, you have to balance x and y directions. Just like x direction if you balance, T2 cos 30 equal to T1 cos 60 and W weight equal to y direction, T1 sin 60 plus T2 sin 30. So if you solve these two equations, then you can find T1 and T2 values. Now one more question. A weight W is suspended from the point of a rope with its ends at the same level. Okay. As a result, the rope is no longer horizontal. The minimum tension required to completely make the rope. See, there is a rope now fixed between two supports, suppose. Now, when you hang a weight from it, then it will become like this actually. So, here the weight. Now, here one tension, T1, T2. Now, let's take, it is having some angle theta. That means now here, if you take the components, see, this is T1 cos theta, also T2 cos theta, and in this direction, T2 sin theta, and here T1 sin theta. And here comes W. Now, T2 sin theta must be balanced by T1 sin theta. So that T1 should be equal to what? T2. Now W should be equal to T1 cos theta plus T2 cos theta. But here, generally, this is the procedure when you hang it from the middle point. But look at the question correctly. A weight W is suspended from the midpoint of a rope with its ends at the same level. As a result, the rope is no longer horizontal. The minimum tension required to completely make the rope straight. So the rope will bend and it is no more straight. But the rope should be straight means the angle should be how much? 0. So the angle should be 0. Then what condition you will get it? Here, see here. In a common sense way, you can say that it should become so strong so that it will not bend. That means it should become so strong means the tension should be very high. Just like what? Infinity. Or here from this mathematical equation also you can understand. See, T1 equal to T2. So if you add, this will become 2T cos theta. So now T will become W by 2 cos theta. But as the string should be straight, then theta should be 0 degrees. Then cos 0 how much? Cos 0 is, sorry, the tension, the angle should be 90 because it should be straight. Now the angle will become 90 means cos 90 how much? 0. So something by 0 is how much? So then it will become infinity. So the tension should be infinite. So that way you can understand what is the angle, what is the tension should be in the string so that the string becomes completely straight, tight. So it should be, see, if the tension is less, it will bend. If the tension is good enough that it can resist, then it will be strong, it will be straight. So that is what the concept. So in a general way you can understand and you can directly choose it is infinity because it should be straight means the tension should be very high, nothing but infinity. Or you can take the mathematical procedure and you can take that the angle should be 90, that means tension will become infinity. And one last and final question. Here they have given very directly that there are few forces are acting at one particular point. Now they have given x and y axis also, and F3 is acting along y, but F1 is not acting. So that we will take component F1 cos 30 and F1 sin 30, and F2 also same thing. This is F2 cos 60 and this is F2 sin 60. Now it is in equilibrium means again we will balance both the directions. That means x direction f1 cos 30 equal to f2 cos 60. One equation will come. Another one f3 equal to f1 sin 30 plus f2 sin 60. Now here they have given f2 value and they are asking f1 and f3. Now when there is f2 value you can find f1 because f1 will become f2 cos 60 is 1 by 2 by cos 30 is root 3 by 2. So 2 get cancelled. So that f2 by root 3 they have given f2 value. After finding f1 value then you can substitute in the next equation, then you can find f3 value also. So this is how you have to deal with the equilibrium of a system, where you need to know what are the natural forces, what is the tension, what is the normal reaction, and what is the weight of a body. And here I'll tell you something like, as I said, if there is a system is in equilibrium, like, see, take a system like this. So many particles are attached with multiple strings, or many particles are placed one above the other and all are in equilibrium. Now here at any point tension equal to total weight hanging from that point. Like if this is M1, this is M2, this is M3 and this is M4, then tension at the given point is, what is the total weight hanging is M1 and M2. So M1 plus M2 into G. Same way when there is a contact, there is a normal reaction and at any point the normal reaction is total weight above it, above the interface. Here total weight below, here total weight above. Now let's take like M1 and M2, M3, M4. Then normal reaction will become M1 plus M2, M2 plus M3 plus M4 into G. So this is the normal reaction. So normal reaction is the total weight above it, tension is the total weight below it. So such kind of questions also they will ask based on the equilibrium. And I have given few examples for the practice as usual. So please practice all the examples, then you will get the idea. So thank you all of you. Will continue in the coming session with